So yesterday we refreshed with just fractions, just numbers. We said that you look at just the denominators and you ask yourself what's the number that every single denominator will divide into. Sometimes it can be one of the denominators that's already there, and then sometimes it's a denominator that is not there and you have to come up with it. And the way to come up with it is focusing on the largest denominators multiples. Now let's throw polynomials in the mix. These 4 questions are simply trying to train you to find the correct LCD. We're not adding or subtracting yet. So you're looking at all of the denominators. There's multiple ways to teach this. So the way that my mind sees it is I focus on any numbers that are coefficients. Since these have no plus or minus signs, then you can think of them as like individual. You've got 4, you've got 2, you've got 8. Then you've got, 4, 2, and 8. Then you've also got x squared. Now here's where I stack them. And then you have x, and then you have x, right? Okay, so the LCD for a polynomial, very similar to with numbers, you start from the largest number. So in this case, the LCD would be what? 8, yeah, because 4 will go into 8, 2 goes into 8, 8 goes into 8. So 8's our LCD, numerical LCD. Polynomial LCD, instead of thinking as the largest, because you don't know any value, you just know x squared. Think of it as the most complicated, most intense. So x squared is the most complicated, right? This is plain old x, but this is x squared. So this is your LCD if the other terms would divide into it. Will x divide into x squared? Yeah. And when I say will it, I mean like imagine, oh yeah, it'll divide into it. So that means it's a multiple. So the LCD of those 3 is going to be x squared. Then you say, okay, so the LCD is 8x squared. The goal is that the denominator can be written underneath whatever you found the LCD to be. The denominator can be written underneath it. So all I did here was put the denominator under each fraction, under my LCD. And I'm visualizing, would the denominator cancel completely? Like, would it divide completely into my numerator, my LCD? And the answer is yes here. Do you see that? They would all, like the 4 would go into the 8, the x squared would disappear, 2 would go into 8, the x here would disappear, 8 goes into 8, the x here disappears. Does that make sense? If you do this and something doesn't divide up, then that's not the right LCD. Because the goal is you should have no more fractions. So the LCD here is 8x squared. Number 4, I'm going to write it a different way because this is obviously more complicated. We've got 8xy squared. We've got 5x squared y. And we've got 4x. You will notice that I stacked them and I lined up the like variables. Because now what I want you to do is to come down underneath. Now with the numbers, focus on the multiples of the highest number. Highest number is 8. Alright, so let's go with multiples of 8. 16 won't work. Times 3, 24 won't work. Times 4, 32 won't work. Times 5, 40, and yes. Okay, so it's 40. by the way, your calculator will produce the LCD of just numbers. It's under the math button, and then under the number column, I think it says LCM instead of LCD. I don't remember what it says, but anyways, your calculator can do that for you as a check. It cannot do it with variables. The reason I want you to stack the variables, notice they're all surrounded by multiplication, right? So this is where this is really helpful. You're going to take the variable with the highest exponent. So that would be what? For x, x squared. And then once again for y, now this one doesn't have a y, that doesn't matter. The LCD will have to, correct? So it would be y squared. All right, you should be able to do 5 in your head. Probably without very much writing. What's the LCD of 5? 2x. Because if you think about it, if I had a fraction with 2x on top, will this x divide into that? Yes. And of course, if I had a fraction with 2x on top, 2x would divide into that. So the LCD here is 2x. Now, that's with polynomials that are just like single terms. You know, there was no plus or minus signs. Now let's look at some plus and minus signs. Once again, I want you to think of it as those wooden blocks with the polynomial painted on the front, x plus 1. And then you have another one, x minus 2. Okay? So we're going to find our LCD. Now, when I stack them, I always stack polynomials that match. This does not match, so I don't want to put it underneath it. I'm going to go over here and kind of write it to the side. And now I want you to think, coming straight down, the LCD is going to be the last name that encompasses each fraction's last name. I say last name to try to help you understand it easier. Now let me use the math word. The denominator that you need is going to be the one that encompasses the denominator of each fraction. So it's like trying to include everybody with a hyphenated last name. Okay? So the LCD here would be x plus 1, x minus 2. When you get the polynomials that have plus and minus signs like this, there is no LCD that you think of that everything will go into, like with numbers. You know, you focus on, oh, 8, what are the multiples of 8? You don't do that when it's just plus and minus sign polynomials. You just generate the LCD by shoving them all together, which is what makes it easier. But some people struggle to wrap their mind around that. You're just putting it together. You're saying that if I had that in the denominator underneath these expressions, those expressions would divide into it, right? Okay, so that had nothing, oh wait, there's 2 more. 2 more practice. 7 and 8, you try them. Because I gotta leave in like 10 minutes. Seven does have a slightly different denominator, and it's right here. What do you notice about it? It is a difference of squares, and you do want it in factored form when you're trying to come up with the LCD. So in factored form, that would be very good. And if it helps you, put parentheses around the polynomials that would be like the wooden blocks, so that way you don't accidentally separate the pieces. Like that's a polynomial, that's a polynomial, it's a block. You can't pull it apart. Okay, so we're going to come up with the LCD that would encompass all of these denominators. So let's stack them. We've got one fraction with this. We have one fraction with this. Notice I did not put it right underneath it because I'm visualizing what they already have in common. Then I've got the one fraction with this. Right? Now, coming straight down, what would encompass everyone's denominator? Yeah, that right there is all I need. Because if you come, like, this is a 1, this is a 1, so okay, you gotta have it. Just for 1 power. And then here's, this is a 1, this is 1, gotta have it. So that would be the LCD. Okay, 8. This has a what? This has a GCF. Pull it out. So you need to be able to see what each of the factors are to get the correct denominator. If you need to make a note, always factor before finding LCD. So this would be x parentheses x minus 4, and that's a block, and that's just x squared. Okay, so let's just list our denominators. We've got x minus 4. Then we've got x minus 4. Then we've got x squared. Where should I put that? I should put it right here. Now, coming straight down, take a little bit of whatever's there, and if it's an exponent, if they have the same base, but there's a difference of exponents, you go to the highest exponent. So this would be x squared, and then x minus 4. Good news and bad news. Good news. The hardest part of adding and subtracting rationals is figuring out the LCD. Bad news. Once you figure out the LCD, then you multiply it by the expression, and that's where some people struggle with the multiplying. They don't cancel things correctly. So I'm going to show you, there's 2 techniques for doing this. I'm going to show you the technique that I do that eliminates the fraction in the very next step. The very next step, you should have no fractions. Right? Yay! Okay. The other technique keeps the fraction until about step 3, and then the fraction disappears. And in my opinion, I want to get rid of the fraction as soon as I can. All right, let's fill in these blanks. Factor. Says if necessary. I think that should say like if possible, but always factor completely. You get a common denominator and you find the LCD to create the equivalent fractions. We're not solving here, so actually we must still have fractions. When we're solving our fractions, then you add or subtract the numerators. And of course we keep our denominator. When we get to, I'm trying to think, I think it's chapter 3 or 4, this will come up again, but instead of it being an expression, it will be an equation. Okay? And this is why you need to know how to do this. Because once you get the LCD, you're going to multiply by it, and then the fractions disappear. Right now we have expressions. Okay. Repeat what we've already been doing. Find the LCD. Leave some space. Find the LCD here of 12x and 6. So you have 12x and then 6. LCD? Do what? 12x. So this fraction, does it need it? Does it need an adjustment on the denominator? No. So I'm going to bring it down. The second fraction needs what to become, on the bottom, 12x. It needs times 2x. Now remember from the very first example we did yesterday that you don't want to change the value of that fraction. So once you figure out what it needs, and it helps to have a roadmap, like write what you know it's going to end up with, then come up here and say to yourself, so this times what would yield this, write it, and then put it, repeat it in the numerator because that's your fancy 1. That's how you're multiplying by 1 without actually changing the value of the fraction. And then just multiply straight across. So 7x times 2x is 14x squared. Now you can write this as one fraction with your LCD. And these are not like terms, so you will just write it 5 plus 14x squared. Technically, what should go first? 14x squared technically should go first. But if you were to write that, I would not mark it wrong. It's just usually the standard form is any number that has no variables called a constant, and it always goes at the end. But that's the answer. All right, number 10. We're finding the LCD of x minus 3 and x plus 4. So what is it? Shove them together. Which means each fraction is going to need adjustments, right? You can come over here and try to squeeze it next to the problem itself. Or if it's too crowded because you're multiplying binomials, here's a technique. You know what's going to happen. You know it's going to come to what? One fraction, right? With what in the bottom? You know that's the goal. So if you know that by design, you can say to yourself, okay, that crap is going to become something over my LCD, right? And then you can now just go back up here and very carefully think to yourself, this, just copy exactly what you see. This was here, and it would have had to be multiplied by what part of the LCD? What did it need? It needed x plus 4. Now, copy the sign here. Copy that sign. It's right there. Plus, copy that. 2x. What did that fraction need? X minus 3. That's the answer. It's just not cleaned up. But that's the answer. Now it's just a matter of, do you know how to multiply and combine like terms? So that's the hardest part, is getting it in that form. Now you just clean up the top. You don't have to clean up the bottom because the whole goal was to be able to see your LCD. So I'm not expecting you to clean the bottom up, but the top, when it looks like that, you do need to multiply it. And this is where that whole, since it's a binomial times a binomial, first, outer, inner, last is very helpful. So here, this is multiplying. I would have x squared plus 4x minus 2x minus 8. Here, this is just distributing. Right? I call this an aside, where I say to myself, I'm going to go over here to the side and I'm going to clean this up and then I'm going to put it back in the fraction. So I'm not rewriting the whole fraction over and over and over. You don't want to cancel. Remember the goal? The goal was to be able to write it as one fraction, which means you're going in the reverse direction of canceling. Canceling would be if I had given you the fraction and said, I want you to factor this and then simplify it possible. That's the canceling. So go the other direction. Alright, so this would be 3x squared plus 2x minus 4x minus 8. And I'm not looking for you to try to factor that. This is what I'm looking for as your answer. Putting that back in the top over your LCD. I want to see your LCD. And that's the answer. Okay, I have time for like one more, so I'm going to do the difficult one. I'll give you the answers to 11 and 12. 12 wasn't tricky. I'll show you the trick in 12. I'll work 12 real quick, give you the answer to 11, and then I'll work 13, and then I have to go. Okay, the answer to 11 is, now there's two ways, so if you multiply the top, and I'll write that, if you multiply the top, this is the answer. Now, if you try 11 and you can't get to this, I bet it's because it's what? It's right here. Subtracting. Which means that once you figure out what needs to be multiplied in the top, when you carry this down, this is subtracting. In this case, it would be minus 3x, but then you're going to have something here. You probably can already see. This is going to need x minus 2. But when you do this, this is negative that is going to change the signs of what you're multiplying by, and that didn't happen in our previous problem because it was addition. So if you get it wrong here, look and see if it's because you forgot that it was subtracting, because it's going to change the signs of whatever it's multiplying by. Okay, I hear you snoozing. All right, 12. What do you notice? They almost look identical, but they're swapped, right? So if it's confusing, swap the order. So let's rewrite this. Keep the signs there. You see that? Same thing, right? All I did was shuffle it. Now what do you notice? They're exactly the same with completely different signs. Not a difference of squares. That's not the same. That's not this. Notice the x here is positive, here it's negative. The 3 here is negative, here it's positive. Watch how this is manipulation, and this will come up like 2 or 3 times. This is pure manipulation here. If I pull a negative 1 out of that mess, I would end up with x minus 3. Do you agree? If I pull a GCF of negative 1 to the front of that mess, now they match. Right? So because this was subtracting and I just factored a negative 1, that when you subtract a negative, it yields a positive. So now I can rewrite this entire expression. I'm leaving the first fraction alone. I just generated a negative GCF that now forces this to be an addition problem, and the denominators now match. No LCD required because it's already there. Does that make sense? This is a manipulation problem, and it will happen a few times. I think there might be one example on your review packet. So now I can write my one fraction. My denominator is this, and going across the top, it's as simple as x plus 6. And I wrote my fraction part way too big. So I don't know if you want to watch or write, like watch out, or maybe not watch out, watch this. Because it's kind of like a little magic trick, you know, you noted, and now the only time it works is when every single term has the completely opposite sign. That's the only way it would work. Like if this had say if that was positive there, this wouldn't have worked, and you would have had to create an LCD. But, well, no, if it was addition, you could still factor that negative GCF out. Are you saying if this was a positive here, then yeah, you could still factor that GCF out, but then it would become a subtraction problem, yeah. All right, let's do 13 real quick, and then I gotta go. I'm here unpaid. Okay, you gotta factor. You gotta factor all of the denominators. So this one's done, right? This is a block. This A is 1, which means we can go straight to parentheses. Factors of -2 that add up to +1, 2 and -1. All right, so let's generate our LCD. So my first fraction has this. My second fraction has this. So what's my LCD? It's just both of them, right? So I'm going to show you the technique again. I'm going to show you the technique again that allows you to go straight to your fraction with the same denominator, and then you just have to very strategically across the top write exactly what you would get. Don't try to multiply it in your head. Don't try to create another shortcut on top of already a shortcut. Don't do that, because then you make room for mistakes. I know that this entire thing is going to come down to one fraction, and I know that's my denominator. I know my first fraction, did it need anything? No, my first fraction was fine. The LCD in the first fraction is the denominator in the first fraction is my LCD. So this one is fine, which means you just copy it. Then copy the sign of what you're doing. Here's where you have to be careful. How many terms are in the numerator of the second fraction? 2. Terms are separated by plus and minus signs, right? How many terms are here? There's 2. That's a block, yes? You need to put parentheses around it. It's a block because it's fixing to go right after a subtraction sign, which means there's a distribution of -1, that if you don't recognize that as a block, you would end up forgetting to change the sign of that second term, and you get the wrong answer. So I'm going to copy what I see, but use parentheses. And then now I'm going to write what that whole fraction needed from the LCD. What did it need? It needed x plus 2. Now you have the correct answer, it's just not cleaned up. So do your little aside. So I'm going to copy this mess, minus, and then I'm going to leave parentheses, and I'm going to multiply that binomial times binomial.
Why should we factor that first?
Because these examples don't have any holes or don't have any holes in the graphs, because I just want you to practice, getting the LCD and combining the fractions. Does that make sense?
Yeah,
If you also, I don't think it factors. There's a GCO that's 3, but it doesn't serve a purpose. It's not going to get you anywhere. It's like a, what is it? It's like a moot point. All right, x plus 3 times x plus 2. What's that going? X squared plus 5x plus 6. Now distribute the negative. If you want to factor the GCF and then factor the polynomial, you can. It can create more chances for mistakes if you're still working on getting an LCD and combining like terms. It's one of those techniques where once you get comfortable in the math, then you decide which route you want to go. Right now, I just want to get you comfortable, find the LCD, and then multiplying what is needed to get the one fraction. All right, combine like terms. 3x, so that's 2x squared plus x minus 3. Okay, putting it back together in my fraction. So we've got 2x squared plus x minus 3 over x plus 2, x minus 1. I shouldn't have circled that. Let me show you this. 4. I'll take that. If you can get there, I'm happy. Okay? If you can get there, I'm happy. If I tell you to simplify the expression and find any holes or any holes, then that means at some point you do need to check and see if it will factor both top and bottom, and then show me what cancels. If it just says simplify, I'm fine with you getting here because you've just gone through the hardest part, okay? Will the top factor? Yes. Let's do the fraction shortcut. Factors of -6 that add up to +1. 3 and -2. So make your fractions 8x over 3 and -2. This one's done, right? This one becomes x over -1. Now it's done. And then now you see a hole in the graph. Does that make sense? Which is why I wanted to work this one, because this hasn't happened on the others. So, if I just say simplify, I'm fine with you getting here. If I say simplify and state any holes in the graph, I need you to get here. Okay? And there's two ways to do that. You can factor first up here, state the whole, then find the LCD. Your LCD will be different along the way. If the whole was x minus 1, your LCD won't have the x minus 1 in it had you gone that route first. If you are still working on like finding the LCD and multiplying, then just keep practicing that until you get comfortable with it to recognize if there was a hole in the beginning or not. Okay? Now you should be able to do the add and subtract practice problems in your chapter exam review. And I think I even posted several iExcels, and I'm not taking a grade on them. They're there if you just want to try a few and know if you're getting them right. Okay? Monday we will do solving equations and the square roots stuff. Tuesday review, exam Wednesday. Okay? Alright. Oh, let me see.